Hello, my name is Antonika Colbert,
And I am Jeffrey Arcilla.
and today we would like to help you understand more about the thyroid gland.
So, first, what is your thyroid? Your thyroid is a two-lobed butterfly-shaped endocrine gland that is located in your lower neck, inferior to the larynx and anterior to the trachea. This two-lobed gland is connected by the isthmus and plays a key role in the metabolism, growth, and maturation of the human body.
As you can see in this picture, the thyroid gland is made up of both the parathyroid and thyroid glands. However, let's take a closer look at each of these glands that make up the thyroid gland, for they both have distinct different functions. When taking a closer look at the parathyroid gland, it is important to take a look at the actual components of this gland. The parathyroid gland is made up of chief cells, oxyphil cells, and capillaries as well. It is important to recognize that its main function is to maintain the body's calcium levels. With that in mind, the chief cells are the cells that synthesize and secrete parathyroid hormone, which is responsible for maintaining the calcium balance. As for the oxyphil cells, they increase in number with aging. However, the function of the oxyphil cells is still unknown. On the other hand, let's take a closer look at the thyroid gland. When you take a look at the thyroid gland, you will see that the thyroid gland is made up of a single layer of cuboidal epithelial cells, colloid filled follicles, follicle cells, and parafollicular cells. The colloid filled follicle is what makes the thyroid gland so special because this is where it stores its hormones, thus being the only endocrine gland that stores its hormone outside of its cell. The follicular cells are the cells that surround the colloid filled follicle and allow for important elements to enter, such as iodide, a key player in the thyroid gland. Finally, the parafollicular cells are the cells that are responsible for secreting calcitonin. However, while it is important that you know the different parts of the thyroid, aren't you curious on how this small gland in your neck produces hormones that have such a large effect on your body? Well, to understand this, we must take a look at the thyroid hormone synthesizing pathway.
The pathway for the thyroid gland has 7 distinct steps. Step 1 starts with the thyroglobulin being synthesized in the rough ER. Once it is done, the thyroglobulin is sent to the Golgi apparatus for further processing. Once this processing is done, the thyroglobulin enters the secretory vessels of the Golgi and buds off and enters the apical side of the follicle cell. Secretory vessels then fuse with the apical side via exocytosis, thus releasing the thyroglobulin into the follicle of the lumen. Next is step 2, also known as the iodide trapping step. This step is done through secondary active transport. Starting with the sodium-potassium pump, a concentration gradient is created. Once that gradient is made, the sodium that was forced up the concentration gradient will want to go back down it. It does this via the sodium iodine symporter. This symporter brings 2 sodiums into the cell, but at the same time, 1 iodine hitches a ride in the symporter and becomes trapped in the basal side of the follicle cell. Next is step 3, where pendrin, which acts as the ion exchanger, transfers the iodine into the lumen of the follicle. Once in the lumen of the follicle, thyroid peroxidase, or TPO, will convert the iodide to iodine by oxidizing it. Next is step 4, known as the organification of iodine. This is when the iodine attaches to the tyrosine in the colloid, forming diiodotyrosine, or DIT, and monoiodotyrosine, MIT. In step 5, the iodinated tyrosines will now link together to form thyroxine, or T4, which is formed by linking 2 DITs, and triiodothyronine, or T3, which is formed by linking 1 MIT and 1 DIT. Step 6 involves the thyroglobulin, which is now attached with T4 and T3 to be endocytosed from the lumen back into the follicle of the cell. Once it is back in the follicle, lysosomes attach to the thyroglobulin, which finally, in step 7, the lysosome enzymes cleave T4 and T3 from the thyroglobulin via proteolysis. MCT8 and other transporter proteins then move the hormone from the basal membrane into the capillaries so that once in the bloodstream, the hormone can go to target tissues. Phew, that was a lot.
Oh, hush your fuss. That is not that much. All in all, the thyroid plays a major role in our body, which is why it is important to stay healthy and keep iodine in our diet.
Created using Powtoon.